Lagrange points, boarding stations to the multiverse. What are Lagrange points? Lagrange points are named after the French-Italian mathematician Joseph Louis Lagrange. These points are also called libration points or L points. This video is made by Dr. Sujata Virdhe, former space scientist with the Indian Space Research Organization. Simply stated, there are always 5 Lagrange points L1 to L5 for a two-body gravitational system anywhere in space. So what does this mean? Well, for example, the Earth-Moon system has 5 Lagrangian points. Let's call the Lunar-Lagrange points LL1, LL2 and so on up to LL5. Similarly, the Sun-Earth system also has 5 Lagrange points. Let's call them the Earth-Lagrange points EL1 to EL5. In the same way, we have several other systems such as the Sun-Mars system, the Sun-Jupiter system, or even the Mars and Mars's moons system, a system for Jupiter and Jupiter's moons, and so on. So you can see that the outer space has many numbers of Lagrange points. However, for better clarity, we will restrict our discussions to the Sun-Earth and the Earth-Moon Lagrange points. So what are Lagrange points? These are specific positions in space where the gravitational force nullifies. If we place a small third body like a spacecraft or a satellite in the orbit around these Lagrange points, they will remain in orbit quite effortlessly around these points. They virtually need almost no amount of propellant. These Lagrange points are not merely of mathematical curiosity. They're already practically being used by spacecraft for exploring the solar system. At any of the 5 Lagrange points, a spaceship can maintain a fixed position with minimal effort. Therefore, Lagrange points are perfect for long-duration space missions. The 2 points L4 and L5 are in stable equilibrium. In other words, if a spacecraft placed at this location gets perturbed or disturbed for some reason, it will naturally return to its original point. The first 3 Lagrange points, L1, L2 and L3, however, are unstable. Spaceships placed at L1, L2 and L3 will drift away at the slightest disturbance. They need to maintain their orbits by firing their thrusters about once every 15 days. The Sun-Earth EL1 Lagrange point is suitable for making observations of the Sun as well as the Earth systems. EL1 lies between the Earth and the Sun at about 1.5 kilometers from the Earth, facing the Sun. Spacecraft here are not shadowed by the Earth or the Moon. EL1 is suitable for solar observatory space telescopes. Examples of space missions at EL1 are ISEE-3 in 1978, Discover in 2015, SOHO in 1995, ACE in 1997, and Aditya L1, which is a planned space mission. The Sun-Earth EL2 Lagrange point is yet another good spot for space-based observatories. EL2 is located 1.5 million kilometers directly behind the Earth as viewed from the Sun. Since sun rays get partially blocked at EL2, a space telescope placed at this position can have the advantage of passive cooling. Examples of space missions at EL2 are the Herschel in 2009, Planck in 2009, Gaia in 2013, and the upcoming James Webb Telescope. Lagrange points EL3, EL4, and EL5 are not found suitable so far for space missions. The Earth-Moon Lagrange point LL2 has seen a couple of space missions as well, such as Artemis in 2001 and Chang'e 5 T1 in 2014. Okay, we now have a fair idea about Lagrange points and their usefulness for specific purpose space missions. But Lagrange points are much more. They are interplanetary superhighways. In fact, Lagrange points are so useful that they act as much more than a parking space for spaceships. They also play a crucial role in traveling around the solar system while using almost no fuel. The unstable Lagrange points L1 and L2 are the important ones. They are the stepping stones in interplanetary travel and gateways for very low energy transfer orbits. Moving within the gravity field of the solar system requires energy, but the energy needed for 1.5 million kilometers journey from LL1 to EL2 is only 0.01 kilometers per second in speed. This speed is no faster than that of a cyclist. Well, it turns out that using an interplanetary superhighway trajectory, you can go from the Earth to the Moon LL1 point, to the Sun-Earth EL1 point or back within a course correction of 50 meters per second. The fact that the energy levels of this Lunar-Lagrange and Earth-Lagrange point are so similar is purely coincidental, but it opens a fabulous opportunity for space exploration. There is an ultra-low energy pathway between these two crucial points in space, meaning spacecraft can travel between the 2 points with virtually no fuel. Portal to the stars and beyond. Our solar system is interconnected by a vast system of tunnels around the sun generated by Lagrange points of all planets and their moons. This natural interplanetary superhighway provides ultra-low energy transport throughout the Earth's neighborhood. The lunar L1 orbit is also an excellent point of departure for interplanetary flight. The lunar L1 is a hub for space transportation, the magic trajectory that unlocks space exploration near the Earth in the upcoming future. Earth's Lagrange points are linked to those of Mars or of Saturn by these minimal energy trajectories. Jupiter has Lagrange points associated with each of its many moons, all joined into an interlinked web. And the system is not stationary. It is an ultra-complex heap of twisted interplanetary spaghetti. There are possibilities of generating artificial Lagrange points as required as well. This is currently done using what we call the solar sail. Lagrange points are magical super reality of the interplanetary intergalactic travel. Truly hardcore science and mathematics of the multiverse. To know more about space exploration and more unique physics, please subscribe to this channel.